Hello, my name is Jonathan Haggerty, and today I'm going to be presenting over the Mannford Veterinary Center. Now, on today's agenda, we're going to be covering this project specifications, the historical geotechnical report, the boring logs, and the dewatering and SWIP plans. So, to give you a bit of background, Mannford is located west of Tulsa, and it's landlocked between three parts of the Keystone Lake in a little peninsula. We're going to be building a vet clinic here, and the address is going to be West 31st Street South and Bowman Road. So for the TYP specifications, the main thing to take here is that it outlines the required fill and compaction requirements. The fill must be made up of the backfill that's excavated from the project, unless it is ineligible. Appropriate materials for fill or backfill include granular fills with approved rock fragments. So that's going to be like gravelly sand and stuff like that. You don't want any expansive silts or clays or anything with a liquid limit greater than 50. And for the building specifications, it has to be compacted to 95% under the building area. And for the landscaping around it, you can do 90% compaction. So when we look at the historical geotechnical report, it says that the subsurface soil they found was consisted of medium plasticity silty clay, lean clay, and sandy clay before it hit rock, and that went down about 31.5 to 41.5 feet. They rated it as a seismic site class D for earthquakes. And when they were drilling it, a 1.375 split spoon sampler was used on an auger drill to collect the sample, and it was transported in watertight protective containers. So now let's take a look at the boring log. So as you can see here in this picture, I've put the side of the veterinary center, and you've got boring 1, boring 2, boring 3, and boring 4 located on there in a rectangular fashion at any end of the rectangular footing. So the elevation of this area is between 880 and 890 feet, and the elevation is the highest at the northeast corner and lowest at the southwest corner. So mostly there's top loam at the surface, meaning that this site has most likely already been messed with and imported fill. There's about 5% rocks and surface bedrock in there, but not enough to classify anything. The top layer is fine sandy clay loam, which then turns into red sandy clay according to USDA and OGS maps. And the groundwater table is only between 3 and 5 feet using the USGS water side. Lithic bedrock was encountered between 35 and 50 feet, which means that you're not really going to be drilling greater than 35 or 40 feet when you hit that lithic bedrock, but we made an assumption that it goes all the way down. So as you can see in this picture, we have 3 dewatering systems, sump pumps for the trenches, which connect into the deep water wells, which will be used for groundwater lowering to around 10 feet, since we need it for such a high groundwater table. And then we've got our culvert ditch that's going out at this southwest end here, according with the slope. For our SWIP BPMs, we've got an aggregate layered covered entrance. We've got vegetative cover around the north side and west side of the property. We've got an inner silt fence inside the trench. We got protection for storm inlet drains on the outside roads, and we've got connection with the culvert to the dispersion ditches already made for the road. That's the presentation. Thank you for watching.